Download this code from codegive.com, link in the description below. Ableton Live crashing, diagnosis, troubleshooting, and code examples for stability. Ableton Live crashing can be one of the most frustrating experiences for music producers. It interrupts creative flow, potentially causing lost work and a general feeling of unease. This comprehensive guide explores common causes of Ableton Live crashes, detailed troubleshooting steps, and even delves into potential code examples, using Max for Live, to address specific stability concerns. Understanding the problem, types of crashes and their symptoms. Before jumping into solutions, it's essential to understand the nature of the crash. Differentiating between types of crashes helps narrow down the culprit. Sudden crashes, no warning, the application abruptly closes without any error message. This is often caused by a critical error in the core program or a low-level system issue. Frozen interface, hang, Ableton Live becomes unresponsive, the spinning wheel appears, and you can't interact with anything. This often points to resource starvation, infinite loops in plugins, or driver problems. Error message crashes. A specific error message appears before the crash, giving you valuable clues. Common messages include: Ableton Live has stopped working, Windows. Ableton Live quit unexpectedly, Mac OS. Assertion failed. Out of memory. Audio engine overload. Consistent crashes during specific actions. The crash consistently happens when you load a particular plugin, perform a specific editing action, or work on a certain project. This strongly indicates an issue with the specific element triggering the crash. 2. Immediate actions after a crash. Don't panic, easier said than done. Keep calm and avoid repeatedly launching Ableton Live immediately. This can sometimes exacerbate the problem. Force quit/kill process. If Ableton is frozen, use your operating system's force quit feature, Ctrl+Alt+Delete on Windows, CMD+Option+ESC on Mac OS, to terminate the process. Check automatic backups. Ableton Live has an auto-save feature. Look in your user library-crash recovery folder. You might be able to salvage most of your work. Enable autosave in Ableton Live Preferences, File Preferences, File Folder. Create Live Sets Backup. Set the interval to a frequency that balances data loss and increased write operations. Document the event. Note down exactly what you were doing when the crash occurred. What plugins were loaded? Which actions were you performing? Was the CPU load high? The more details you remember, the better. 3. Troubleshooting steps, a systematic approach. Follow these steps in a methodical order to identify and address the crashing issues. System compatibility and updates. 1. Check minimum system requirements. Ensure your computer meets or exceeds Ableton Live's minimum and recommended system requirements, found on the Ableton website. A too slow CPU, insufficient RAM, or an outdated operating system can cause problems. 2. Update operating system. Install the latest operating system updates, Windows Update, Mac OS Software Update. These updates often contain critical bug fixes and driver improvements that can enhance stability. 3. Update Ableton Live. Make sure you're running the latest version of Ableton Live. Developers regularly release updates to address bugs and improve performance. Check for updates within the application or on the Ableton website. 4. Driver updates, crucial. Audio interface drivers. This is the most common cause of crashes. Go to your audio interface manufacturer's website and download the latest drivers compatible with your operating system and Ableton Live version. Uninstall the old drivers before installing the new ones. Graphics card drivers. While less common, outdated, or corrupted graphics drivers can sometimes cause issues, especially with resource-intensive visualizations in plugins. Update to the latest drivers from NVIDIA, AMD, or Intel, depending on your graphics card. Other hardware drivers. Check for updates for any other connected MIDI controllers, USB hubs, or external hard drives. Ableton Live preferences and settings. 1. Audio buffer size, latency. A too small buffer size can lead to audio dropouts and CPU overloads, causing crashes. Increase the buffer size in Ableton Live's Preferences, Audio tab. Start with 512 samples and increase if necessary. A higher buffer size introduces more latency but reduces the CPU load. 2. CPU overload. Monitor the CPU meter in Ableton Live, bottom right corner. If it consistently hits 100%, you're pushing your system too hard. Try the following. Freeze tracks. Freeze tracks containing CPU-intensive plugins or virtual instruments. This renders the audio to a static file, reducing real-time processing. Flatten tracks. Convert MIDI tracks with VSTs to audio tracks. This eliminates the real-time processing load of the VST. Reduce plugin instances. Limit the number of instances of heavy plugins in your project. Resample/bounce audio. Bounce sections of your project to audio files, reducing the number of active tracks. Change quality settings. Some plugins have quality settings, example oversampling. Reduce these settings to lower CPU consumption. 3. Disable third-party plugins. Sometimes, a buggy or incompatible plugin can cause crashes. Try disabling all third-party plugins and see if the problem goes away. Method 1. Ableton Preferences. Go to Preferences-File Folder-VST Plugin System Folder. Uncheck Use VST2 Plugin System Folders and use VST3 Plugin System Folders. Restart Ableton Live. This will temporarily disable all VST plugins. If the crashing stops, the issue is likely with the plugin. Then re-enable the folders one at a time to find the problematic plugin. Method 2, Custom VST Folder. Create a new, empty folder for VST plugins. In Ableton's Preferences, point the VST plugin system folders to this new folder. This effectively disables all plugins. Then, gradually add plugins back to the folder to identify the culprit. 4. Rebuild plugin database. Go to Preferences-File Folder-Plugin Sources. Click the Rescan button. This will rebuild the plugin database, which can sometimes fix issues caused by corrupted plugin information. 5. Adjust multi-core/multiprocessor support. In Preferences-CPU, experiment with the multi-core/multiprocessor support setting. While generally beneficial, enabling it can sometimes cause issues on certain systems. Try disabling it temporarily. 6. Disable unnecessary features. Turn off features you don't need, like automatic updates, push integration, if you're not using a push, or certain background processes. See project-specific issues. 1. Corrupted project files. A corrupted project file can cause crashes. Try opening a different project to see if the issue is specific to one project. 2. Remove corrupted samples. Sometimes, a corrupted audio sample can cause crashes. Try removing recently added samples from your project. 3. Simplify the project. Start by removing sections of the arrangement or disabling tracks to isolate the source of the problem. D. Hardware problems. 1. RAM * insufficient RAM can lead to crashes, especially with large projects. Run a memory test to check for errors, example using memtest 86+. 2. Hard drive * a failing hard drive can cause crashes. Check the drive's health using diagnostic tools provided by the manufacturer. 3. Overheating * overheating can cause instability. Make sure your computer has adequate cooling. Monitor CPU and GPU temperatures. 4. Advanced troubleshooting and code examples, Macs for Live. If the above steps haven't resolved the issue, you might need to delve deeper. Macs for Live provides a powerful way to create custom devices that can address specific stability problems. A. Monitoring plugin CPU usage with Macs for Live. Sometimes, a plugin might be behaving erratically and consuming excessive CPU resources, even if the CPU meter in Ableton doesn't immediately reflect it. We can create a Macs for Live device to monitor plugin CPU usage more granularly. Explanation * 1. live.param. This object creates a parameter in Ableton Live that allows you to select the plugin index. This will let you iterate through each plugin on your track. 2. Audio/CPU plugin monitor. This is a custom C++ class that accesses the track information, and returns CPU usage, and plugin name. The code for the C++ class is below. 3. Number objects. These objects display the current and maximum CPU usage of the selected plugin. 4. Live.text objects. These objects display the name of the plugin. 5. Button object, resets the maximum CPU usage value. 6. Patching. The objects are connected to display the plugin information and CPU usage. C++ code for audio/CPU plugin monitor custom C++ class in Macs for Live *. Steps to use the Macs for Live device. 1. Create a new Macs for Live device on an audio track in Ableton Live. 2. Add the C++ to your project. Instructions on how to create an external C++ file are in the C74 Macs documentation. 3. Copy the code above to your new Macs for Live device. 4. Place the Macs for Live device before the first plugin you want to monitor. 5. Add the total number of plugins that you would like to cycle through. 6. Press play in Ableton, and the Macs for Live device will automatically iterate through the plugins you have set. 7. Examine the name of the device, current CPU, and max CPU. 8. Use the plugin index dial to manually adjust the plugin you would like to monitor. B. Preventing infinite loops, audio/MIDI. A common cause of hangs is an infinite feedback loop, either in the audio signal path or in MIDI routings. These are harder to detect visually. Macs for Live can help detect these loops. Audio feedback loop detection, conceptual. This example provides a conceptual approach. A fully robust solution requires deeper signal analysis. Explanation * 1. Scope * visualizes the incoming audio signal. 2. ABS * calculates the absolute value of the audio signal. 3. Snapshot * takes a snapshot of the audio level periodically. 4. * calculates the difference between the current and previous levels. 5. * checks if the level difference exceeds a threshold. 6. Counter * increments a counter if the threshold is exceeded. 7. Threshold dial * allows you to adjust the sensitivity of the loop detection. How it works, conceptual. The device compares the current audio level to the previous level. If the difference is significantly greater than a threshold, it suggests that the audio is amplifying itself, a potential feedback loop. The counter tracks how many times the threshold has been exceeded. Limitations ***. This is a simplified approach. it's easily fooled by normal dynamic changes in the audio. Asterisk it doesn't pinpoint the exact source of the loop. Asterisk true feedback loop detection is computationally intensive and requires analyzing frequency content and signal timing. See protecting against plugin crashes, sandboxing/process isolation. Ideally, plugins should be sandboxed, meaning if one plugin crashes, it doesn't bring down the entire application. Ableton Live doesn't currently have built-in plugin sandboxing to the extent of some other DAWs, like Bitwig Studio. Max for Live can't directly sandbox plugins. However, it can be used to 1. Monitor plugin status * create a Max for Live device that periodically checks if a plugin is still responding, example by sending it a MIDI message and waiting for a response. 2. Graceful degradation * if a plugin is detected as unresponsive, the Max for Live device can * bypass the plugin. * load a pre-rendered version of the audio from the plugin. * display a warning message. Conceptual Max for Live patch * explanation * 1 plugin_index * allows you to select the index of the plugin you want to monitor. 2 plugin_status * indicates the current status of the selected plugin. 3 C++ external plugin * sends a check to the plugin to see if it is responding. If it is not, bypass the plugin. 4 plugin_status * provides visual feedback to the user. Caveats. This requires writing a custom C++ external for Max for Live to interact with the Ableton Live API and check plugin responsiveness. The exact method depends on the plugin type, VST2, VST3, O, and the specific API calls available in the Ableton Live SDK, which is not directly exposed within Max for Live. Bypassing is the simplest action. Seamlessly switching to a pre-rendered version is more complex and requires careful audio routing management. Reporting crashes to Ableton. If you've tried all the troubleshooting steps and are still experiencing crashes, it's essential to report the issue to Ableton support. Crash reports * Ableton Live automatically generates crash reports. Submit these reports to Ableton via the Crash Reporter dialog or by contacting support. The reports contain valuable information that helps developers identify and fix bugs. Detailed description * provide a detailed description of the crash, including your operating system and version, your Ableton Live version, the exact steps to reproduce the crash, a list of all plugins loaded in your project, any recent hardware or software changes you've made, project file, if possible if the crash is specific to a particular project, and if it doesn't contain sensitive or confidential material, consider sharing the project file with Ableton support. 6. Preventing future crashes, best practices. Regular backups make regular backups of your Ableton Live projects. Use cloud storage or an external hard drive. Organize your library. Keep your sample library and plugin folders organized. Avoid having too many files in a single folder. Monitor resources. Keep an eye on your CPU usage, RAM usage, and disk space. Close unnecessary applications when working with Ableton Live. Test new plugins. Before using a new plugin in a critical project, test it thoroughly in a separate, empty project. Stay informed. Follow Ableton's forums and social media channels to stay informed about known issues and bug fixes. Clean installation. As a last resort, consider performing a clean installation of Ableton Live. This involves uninstalling Ableton Live, deleting any remaining application files, and reinstalling the latest version. 7. Conclusion. Ableton Live crashes can be caused by a multitude of factors. By following a systematic troubleshooting approach, keeping your system updated, managing resources effectively, and leveraging tools like Max for Live, you can significantly reduce the frequency and severity of crashes, allowing you to focus on what matters most, creating music. Remember to always document your findings and report persistent issues to Ableton support to contribute to the overall stability of the software. Okay, let's dive into the frustrating world of Ableton Live crashes and explore troubleshooting strategies, including identifying potential code-related causes and how to address them. This will be a comprehensive guide covering various crash scenarios and techniques for diagnosing and, hopefully, resolving them. Understanding Ableton Live crashes, a big picture. Ableton Live, like any complex software, can crash for a multitude of reasons. These can be categorized broadly as 1. Hardware issues * problems with your computer's components, RAM, CPU, hard drive, audio interface, can lead to instability. 2. Software conflicts * other applications running on your system, outdated drivers, or compatibility issues can interfere with Ableton Live. 3. Plugin problems * third-party VST/O plugins are a frequent source of crashes, especially if they are poorly coded, outdated, or incompatible. 4. Project complexity and resource overload * extremely large projects with many tracks, plugins, and samples can strain your computer's resources and cause crashes. 5. Corrupted files * a corrupted Ableton Live project file, sample library, or even Ableton Live's configuration files can trigger crashes. 6. Operating system issues * problems within your operating system, Windows or Mac OS, can lead to application crashes. 7. Code-related problems, Max for Live if you're using Max for Live devices, custom audio/MIDI processing and GUI tools embedded within Ableton Live, poorly written Max code can definitely cause crashes. General troubleshooting steps, before diving into code. Before assuming the issue is Max for Live related, let's exhaust some common troubleshooting steps. This will help you narrow down the problem and potentially solve it without complex code analysis. 1. Update everything *. Ableton Live * make sure you're running the latest version of Ableton Live. Older versions might have known bugs that have been fixed. Operating system * ensure your Windows or Mac OS is up to date. Drivers * update your audio interface drivers, graphics card drivers, and any other relevant drivers. Go directly to the manufacturer's website for the most recent versions. Plugins * update all your VST/O plugins to their latest versions. This is crucial as plugin updates often contain bug fixes and performance improvements. 2. Restart your computer * this simple step can often resolve temporary glitches. 3. Disable plugins * the disable custom VST2 plugin folders trick * in Ableton Live's preferences file/folder, temporarily disable any custom VST2 plugin folders. This forces Ableton to only load plugins from the system default location. If the crashes stop, a plugin in your custom folder is likely the culprit. Selective plugin disabling * if disabling the custom folders doesn't help, try disabling plugins one by one within your project to identify the problematic one. Consider temporarily moving plugins out of your VST/O folders to prevent Ableton from loading them. Isolate newly installed plugins * after you install a new plugin and that's when the crashing starts, then the new plugin is likely the source. Uninstall the new plugin and see if it solved the crashing. 4. Increase buffer size * in Ableton Live's preferences audio, increase the buffer size. A larger buffer size gives your computer more time to process audio, reducing the likelihood of dropouts and crashes, especially with complex projects. Start with a buffer size of 512 samples or 1024 samples. 5. Reduce CPU load * freeze tracks * freeze tracks that use CPU-intensive instruments or effects. Freezing renders the track to audio, reducing the real-time processing load. * flatten tracks * flatten MIDI tracks with lots of plugins into audio tracks. Deactivate devices deactivate any devices that are not actively being used. Simplify projects if possible, try simplifying your project by removing unnecessary tracks, effects, or samples. Create a copy of your project before making changes. Resample to a more efficient audio format, using .wav or .aiff files can sometimes strain system resources. 6. Check your hard drive space * ensure you have enough free space on your hard drive, especially the drive where Ableton Live is installed and the drive where your project files are stored. A full hard drive can significantly impact performance. 7. Monitor CPU and RAM usage * use your operating system's task manager, Windows, or activity monitor, Mac OS, to monitor CPU and RAM usage while running Ableton Live. If you're consistently hitting 100% CPU or running out of RAM, this indicates a resource overload problem. 8. Reset Ableton Live * rename preferences folder * close Ableton Live. Locate your Ableton Live preferences folder. Rename it, example preferences _backup. When you restart Ableton Live, it will create a new, default preferences folder. This can resolve issues caused by corrupted preferences files. The location of the preferences folder varies by operating system. Windows */ users / your username / appdata / roaming / Ableton / live version. Appdata is usually hidden. You may need to enable show hidden files and folders in your Windows settings. Mac OS * library / preferences / Ableton / live version. The library folder is often hidden. Press CMD + Shift+. Period, to reveal it in Finder. If resetting preferences fixes the issue, you can try gradually copying settings from your old preferences folder into the new one to identify the specific setting that was causing the problem. 9. Clean up your sample library * make sure your sample library is well organized and free of duplicate or corrupted files. Consider using a dedicated sample management tool. 10. System File Checker, Windows only. Run the System File Checker, SFC, tool to scan for and repair corrupted system files. Open command prompt as an administrator and type sfc/scano. This can help resolve operating system level issues. 11. Check your computer's health. Open Task Manager, or Activity Monitor on Mac, to check your CPU and RAM health. Close other unused applications to free up resources. Deeper dive, Max for live and code-related crashes. If the general troubleshooting steps haven't resolved the crashes, and you're using Macs for live devices, it's time to investigate potential code-related problems. 1. Isolate the problematic Macs device *. Disable Macs devices *. As with regular plugins, try disabling Macs for live devices one by one to see if you can isolate the culprit. New project test * create a new, empty Ableton Live project. Add the Macs for live device you suspect is causing problems to a track. See if the crash occurs in this isolated environment. If it does, the device is almost certainly the problem. To examine the Max for Live Devices patch ***. Open the patch in Max **. Right-click on the Max for Live device in Ableton Live and select Edit in Max. This will open the Max patch editor. Look for obvious errors. Examine the patch for any obvious errors, such as missing objects, objects with red borders or that are labeled as unrecognized. These usually indicate that a required external or abstraction is missing. Feedback loops. Uncontrolled feedback loops can quickly overload the system and cause crashes. Unbounded loops. Loops that can run indefinitely and consume CPU. Incorrect data types. Connecting outlets and inlets with incompatible data types, example trying to send a signal to a message box. 3 debugging techniques in Max print object. Use the print object to display values at various points in your patch. This can help you trace data flow and identify where things are going wrong. Connect the outlet of an object to a print object, and the output will be displayed in the Max console window. Number and scope objects. Use number to visualize signal values and scope to view waveforms. These can help you identify signal clipping, unexpected values, or other signal-related problems. Timer and puck lock objects. Use timer to measure the execution time of specific parts of your patch and puck lock to monitor CPU usage within the patch. This can help you pinpoint performance bottlenecks. Breakpoints. While Max doesn't have traditional breakpoints like a code debugger, you can effectively simulate them by using a combination of trigger and print objects. For example, trigger bang, message something -print will only print something when the bang is triggered. You can use this to selectively print values or pause execution at specific points. Defer and defer low objects. If you suspect that timing issues are causing problems, try using defer or defer low objects to delay the execution of certain parts of your patch. These objects schedule the execution of a message to occur later in the event queue, which can sometimes resolve race conditions or timing conflicts. 4 common code-related issues and solutions, with examples. Memory leaks. Memory leaks occur when a Max for Live device allocates memory but doesn't release it properly. Over time, this can consume all available memory and cause a crash. Example of a potential memory leak, simplified. Imagine a Max for Live device that creates a new JIT.matrix object every time a button is pressed, but never deletes the old one. Solution: properly dispose of dynamically created objects when they're no longer needed. Use the free message to deallocate memory. In Max 8 and later, the new and delete operators are deprecated and memory management is handled automatically, but be aware of potential issues with older patches. Infinite loops. Uncontrolled loops can consume CPU and eventually cause a crash. Solution: ensure loops have a termination condition. Use a counter and a conditional statement to break out of the loop when a certain condition is met. Max begin _max 5 patcher patcher file version 1 up version major 8 minor 5 revision 5 architecture x64 modern UI 1 class namespace box rect 42.0 85.0 600 and 40.0 480.0 glocked 0 open presentation 0 default _font size 12.0 default _font face 0 Default underscore font name, Arial. Grid and open, 1. Grid size, 15.0, 15.0. Grids Napanapan, 1. Objects Napanapan, 1. Status bar visible, 2. Toolbar visible, 1. Left toolbar pinned, 0. Top toolbar pinned, 0. Right toolbar pinned, 0. Bottom toolbar pinned, 0. Mid toolbar pinned, 0. Timane millisec, 1. Windowing underscore style, decorated. Topmost, 0. Anti-alias, 1. Style. Subpatcher underscore template. Depends. Autosave, 0. Description. Tags. Boxes. Box. ID, obj13. Max class, button. Num outlets, 1. Outlet type, bang. Parameter underscore enable, 0. Patching underscore rect, 113.0, 35.0, 24.0, 24.0. Box. ID, obj12. Max class, new obj. Num inlets, 2. Num outlets, 1. Outlet type, bang. Patching underscore rect, 183.0, 124.0, 40.0, 22.0. Text, gate 1. Box. ID, obj10. Max class, number. Num inlets, 1. Num outlets, 2. Outlet type, bang. Parameter underscore enable, 0. Patching underscore rect, 60.0, 236.0, 50.0, 22.0. Box. ID, obj8. Max class, new obj. Num inlets, 2. Num outlets, 1. Outlet type, int. Patching underscore rect, 60.0, 176.0, 36.0, 22.0. Text, +1.